Or you keep it at 0 point, you on it. So you press this to put it at 0 point. It's already in gram. It's already in gram. So you can see that this is already in 0 gram. So we are measuring 0 point, 8 point what?
8.0 grams.
So we are using this sodium carbonate. Let's use sodium carbonate. But what we are giving is sodium what? Bicarbonate. So we are going to measure this. This is the mass of this paper. This filter paper has already been detected. But we are going to cancel it by pressing here. If you press here, you remove the mass. So you don't become the mass of this will not be detected again. Is that clear? Now I have to measure 8 point something gram, 8.0 gram of sodium carbonate to get to mix it this. So we have this. This is 1.1, no, 2.7. We are looking at 8.0. This is 6.0. 6.9, 7.2, 7.4, 7.8, 8.0. So I'm getting 8.0 is what we are looking for. This 8.0 of your sodium carbonate. So I'm going to mix it with 1 dm cube. That is 1 liter of water. So I'm going to add this. This is acid already. So this is our acid. We have already mixed our acid. We have already added this acid. This is our acid. So we are going to mix our base using a. So we have now added the. Don't start. We have now added the sodium carbonate into the water. Then we have to stir it first. We have to stir it with our stirrer. Stirring it, turn it very well. Make sure that everything dissolves in the water. Make sure everything dissolves. Anyone that did not dissolve, you leave it there. So dissolve everything very well. Make sure you dissolve them. Stir it very well. Stir. So this is now our base. This is now our base. This is now our base B. So whenever you see base B in the hull or anything B for titration is known as what? Base. So this is our base. The acid and base. Great. Just as after this will be measuring cylinder. So this is 500 ml. Now we have already gotten what we need from the reagents. I've gotten them from the reagents. Now the next process is for we to measure out some of these things that we are asked to do. And we have to measure some of this acid. Let's take small acid to this point. Okay, I'll just pull a small acid to this. Let me take this first. Quiet. So this is our acid, taking a small quantity of the acid. Also, I'm going to take a small quantity of the base. Now, what are we going to do? You lock the burette very well. You lock it. Lock this burette. Lock it very well that the acid will not escape. Then you fill the acid here. From here to here is not at 50. This thing 50 milliliters, which is 50 milliliters. So we fill in the acid. Fill in the acid. The acid. Don't allow bubbles to be there. Bubbles, air bubbles. So that is 150 centimeter cube. It's 50 centimeter cube at the volume of the burette. Now you also take small quantity. Now let me just leave the base here. I can take my base here because we are using a pipette of this pipette is 25 centimeter cube. Centimeter cube. So we just have to use the pipette. Pause. Drop it here. This is the base. Yes. Just drop it here. Very good. Now, whenever you are done with this, you put this. The next thing you need to do, maybe you have set this thing, you have to use the indicator. Use the indicator. An indicator is what? Methyl orange. So you take the methyl orange. You just drop it. 1, 2, 3. And when you drop, you shake it. So you allow it. Now the next thing you need to do is this. You have to draw your table of values. Of values. Now you take your burette size. Or let me say the size of burette. Is 50.00 centimeter cube. Volume of, if you don't say size, you can also say the volume of bullet. You can say volume of bullet. The volume of pipette is equal to 25.00 centimeter cube. That's what I used to. You have seen that that's what I used. So when you have that, I will say burette reading. How people are listening?
Yes, sir.
Burette readings. Now you are not supposed to you are listening. You are just trying to take this in. Now you put your final reading. Burette reading is in centimeter feet. Then your final reading first. Centimeter feet. Initial reading. Initial reading is centimeter what? Cube. And the volume of acid used.
You will go back.
Volume of acid used. A. Or you call it the titrate. Also in centimeter what? Cube. So after that, you draw this table very well. You draw your table very well. Then this table. Draw the table. Draw this table. Now you have your rough reading. You have your first reading. You have your second reading. If there is no time, start at second, but if there is more time, you can continue to third reading. Now, this is the burette. And what we feed to this burette is the acid. And from here is 0 point. So the initial reading from when you are now, let me tell you something. First reading, you want to do the first reading to get the first reading. Look at the first reading now. I want to titrate. Now you open this. From here is 0 point. 0 point. So initial reading here is 0 point. Is 0.0. Here is 0 point. The first reading there is 0.0 from here. So when you are putting 0.0 now, you have to check the reading, what you need to get. Now I'll start titrating. I'll open here. Just open this muscle now. Start shaking. Immediately observe the color change. Immediately observe the color change. That is when the reaction has taken place. Leave my main finish. Now your own. Necessary for calculation sometimes.
I'm not off.
We assume that this is rough reading. So this is the color change. So when you achieve this color, that means this is the end point. Now, at this point now, where the reading stop is at 42 point what? And the final reading. That is what? Final reading. Is that clear? Practical properly. So I have to flip back again. How to feedback again. Ask him this. How to feedback again. If it is excess, you remove. Remove headrest. So if it is excess, you use your just have to remove it small. Yes, use this, reduce it small. So since you have done that, you start another practice again. This one you are starting the practical officially now. You also use a pipette. Make small, even like that. So now you also take your this one and add. Do it like that. So you forget about the press. You know that way like the measure. You press it, press it. But if I press like this, press like this. Same thing. So let's go on. Titration. I don't allow you to rush again because you're already getting close to the end point. The end point is when the reaction have stopped. That is the change in color is observed. It's not at the end point. This is the end point you have reached. So you lock because only this change that this is now ordinary water. If I pour acid to the floor, you will see that acid have a kind of reacting property. You see that? Okay, let me use this one. I hope you are seeing what I'm doing. That is what that thing has been doing now. That is the first reading. The other one is second. This one now is second reading. I'll try the second one. So that is that. Take another indicator again. The indicator. 1, 2, 3. Now they can add the class. On the top. I will shake. I'm coming. Changing color. Color has already changed. So what is the value? This is 42.
Quase. Foi 50.
Four zero.
Yes.
That means the other one cannot be. The other one will be 42.60. Can be far. Like giving us 30, so it's very hard. And have such value. Now the last one is called the immediately. See, I can if I start from here now, this one becomes my initial reading. But the level of acid here cannot give me the change in color, so I cannot use from here. I need to feedback. But I mean, I'm studying. The value is stopping at 20 something. I can make my initial reading to start. I can use the remaining one. Is that clear? Yes. That is why I can also. If I look for this one, can also be 2.40. Sorry, initial reading. 2.40. But if I start, okay, I'm communicating here.
Hey.
So this is increase it. So turn it back. So this is that thing we're going to use that day. I have to keep it to it. Yeah.
No, sir.
Somebody should be doing this, okay? You people go to do it yourself. You can break it now. My husband is there. You people can do it. You will start from the way I started my own, from the mixing. I will not have enough water here, that is why. So after you select from the mixing, the engine. So that is what you have there. 2.40, so you can see that there is consistency. For you to get the average volume of acid here, you must subtract this. This subtract by this to give you 42.0. So give us back the value, we started from 0.0. Exactly. Good evening, good afternoon, good morning, depending on what we're watching from. This is Don-Electro-Tech. Like I told you before, that I will be bringing to you the official practical as being conducted by my students, and I believe that with the way they have carried out this practical, you will be able to learn one or two things. I mean, most of you that will be writing Waec this year, 2025, just look at the guide, the procedure that is involved, and what is likely to come out. I'm giving you 80% assurance that some of these things that you see here today, we are about to learn, will likely come out. And I'm very but I'm saying 80% sure that some of these things will come out. If you follow this step, I bet you will come to this channel thanking me. Our practical is very important in chemistry, physics, they are very important, biology, they are very important, but we are talking about chemistry because of some of the issues students find in order to handle some of these practical problems. So I bet you, before you start watching, I would like you to come along with your pen and paper, jot down the questions and follow the procedures. And don't forget to subscribe, like and share this page to others. That is all you can do for me. Thank you very much. Now let's look at this question very well. A is a solution of 0.200 mole per dn cube of hydrochloric acid. B is a solution containing 8.0 gram of sodium dicarbonate per dn cube of solution. Put A into the burette and titrate it against 20 or 25 centimeter cube portion of B using methyl orange as indicator. Repeat the titration to obtain consistent titrate values. Tabulate your result and evaluate the average volume of acid used, which is A. B, from the results and the information provided, calculate the concentration of B in mole per dn cube, concentration of B in gram per dn cube, concentration of A in gram per dn cube. The volume of carbon dioxide measured at standard temperature will be evolved during the reaction. The equation of reaction is given at, note that at standard temperature and pressure, which is STP, standard temperature and pressure, molar volume is given as 22.4 dn cube. This is the equation of the reaction. You can see equation of the reaction. Watch very well. You observe this. So without wasting time, we are going to solve this problem according to the value obtained by my students, which I'm going to display here, how the value we have obtained. I will show you the step-by-step on how they really came about these values. Thank you. Now, from the value obtained by my students, I will be working on these values. Now, like I told you before, the solution, like we have said before, according to the question, we said that you should put into the bullet and other things. So you have to say tabulate your reading. So we have to talk about the table of values. Table of values. In the table of values, we'll talk about some of the equipment used in obtaining accurate results in this experiment. And one of the things that actually helped in obtaining accurate results is the burette. So we'll talk about the volume of the burette used. Volume of the burette used. Volume of the burette used is 50.00 centimeter cube, which is equivalent to 0.050 decimeter cube. So another one again that was used is the pipette, volume of pipette used. volume of pipette used. The pipette used is equals to 25.00, that is what we used, cube, which is equals to 0.025 decimeter cube. How do we get the decimeter point this? We divided by this by 1000, because we know that 1000 centimeter cube is equivalent to 1 decimeter cube. So for you to convert this 50 centimeter cube to decimeter cube, you divide it by 1000. That 50 divided by 1000 will give us 0.050 decimeter cube. This is how we got this. So some of you that don't know how we got this, you just look at it on this other way. Now, without wasting time, I'm trying to acquire the table of value. The indicator used is necktie orange. Necktie orange is used as the indicator. What is the function? Function of the indicator is to show us when the reaction have taken place. So we use necktie orange. Now, for the table of value, we have the Burette readings, the final readings, initial readings, and the volume of acid used. A, or I call it the titled values. So with that, we have what is called the rough value, the rough reading. We have the first reading, the second reading, and the third reading. You can decide to stop at the second reading, like I told you before, but I like applying to the third reading based on time. If you have a lot of time, you have enough time to do all these things. But the minimum that you can achieve or that is allowed is first and second reading. That is second. So you can do up to 4, 5, 6, 7, depend, but you must not do less than what is obtainable, which is you must do at least two. So with this now, the value that was obtained by my student, which I will show you, is the rough reading. We have 42.60. We have 0 initial reading 00, and we also obtained this at the value should be 42.60. But let me tell you something. Waec have changed. Sometimes we don't normally use all the initial reading to be 00. Just take note of that. But let's be using it for now. Now here we have 42.70, and sorry, here it should be 42.70, and here is 46.60. So here I also have 0 at initially we have 00, then we have 42.60. Also the same thing here, it's applicable to here, 42.40 and 42.40. So initial value is 0000. So here we have 42.40 and 42.40. Now let me tell you something here. If you watch the value, like I said in our last video, that the consistency is that the value should not exceed more than 20, at least plus 20. If you watch very well, if you minus this, you have 20, and here is also the same value. So we are within the range. So what do you do? The next question says, what is the next question? The next question says, tabulate your results. So this is the table of your value, which is you have already tabulated. So this is the value that you have already tabulated. This is the question A. And in that tabulation of values, they ask you to calculate the average volume of what? Acid. So average volume of acid. Average volume of acid used, we call it VA, is equals to, well, I say this, what we see, look at the values here in this table. What is obtainable here, that you know that the valid result here is 1, 2, 3. This is the rough reading. We don't use the rough reading in terms of checking the average volume of acid. This is a rough reading. We just use it to test the process, whether the process is working. So we tag this as a rough reading. But when you look at this place now, this is the actual reading that is valid. All this 1, 2, 3 is valid, but here is not a valid reading for now because we call it rough. We use it to test the system. So we say the first reading plus the second reading plus the third reading divided by the number of titration carried out. We carried out 4, but this one is rough. We don't use 4. You cannot say because this is rough. We are not using it, so we say 1, 2, 3 divided by 3 value 3. Therefore, VA, which is the average volume of acid, you add this value which is here. How do we get this value? We say this minus this subtract from this minus this minus this will give us this. That's how we got these values. Now, this one now will now say 42.60 plus 42.40 plus 42.40 divided by 3. This one is the first value, which is the first value here, which is this value. Second value is this one, which is this one, and the third value is this one, which is this one. So when we add up these values together, we now say that 42.60 plus 42.40 plus 42 plus 42.40 again is going to give us 127.40 over 3. So when you divide this by 3, divided by 127.40 divided by 3 is going to give us 42.4, approximately can say 7 centimeter cube, which is the same thing as when you divide this by 1000, according to converting to decimeter cube, so you have 0.04247 decimeter cube. I told you that for you to convert centimeter cube to decimeter cube, you divide this value by 1000. Any number in centimeter cube divided by 1000 to get decimeter cube. So this is the average volume of the acid used. So the next question B, question number B, said from the result, look at it now, from the results and information provided, calculate the concentration of B in mole per dm cube. So the concentration of A in mole per dm cube, like you have seen, is from the formula. We have to relate this equation by analyzing this. We can say that from the formula, we'll now say that CAVA equals to CBVB is equals to NA all over MB. C stands for concentration, while A is acid, B is base, and N is the number of moles. So whenever you see A, you know that this is going like C concentration. I mean, this is concentration of acid, volume of acid. If that V now, where V is the volume. C is measured in mole per dm cube, and V is measured in centimeter cube or decimeter cube. Note all these things. Decimeter cube. So you can see that this is C is concentration, V is volume, A is acid, B is base, D is acid, D is base, N is number of moles, and C is measured. The unit of C, which is concentration, is mole per dm cube, and V is a centimeter cube. So whenever you see CA means concentration of base, while VA means volume of, CA means concentration of acid, and VA means volume of acid. CB means concentration of base, and VB means concentration of volume of base. So NA is the number of mole of acid, and MB is the number of mole of base. Now let's continue. Now when you look at the question very well, you can see that the value that have mole per dm cube is always concentration, and what is that value is for hydrochloric acid, which is the base, which is the acid. We are talking about A. So therefore given parameters, CA from the question, look at CA from the question, say that A is a solution of 0. So the CA here, because this is the concentration, is 0.0200, I think A is equals to 0.200 mole per dn cube, because we say that this concentration of acid and the units for C is always this. So whenever you see this unit, you're talking about concentration. Now, CB, EB is what we are looking for. We are looking for the concentration. Look at the question, say concentration of base in dm bot cube, which is this value, which is, we are looking for this value. So CB is not given. Then what is our VA? VA is average volume of acid. The average volume of acid is given in that question. The average volume of acid is here, which is this value. So we have 0.04247 dn cube. So that being said, we'll now say that VB is the volume of base, that is pipette, when we are trying to pipette this thing. So the pipette the base. So the volume of the pipette used is the volume of the base, which is the volume of the pipette used is 25 centimeter cube, which is something at 0.025 decimeter cube. So we have 0.025 decimeter cube is the volume of base. Now the number of mole Na. Now let's check the number of mole. Look at this question. These are the equation. If you have a question of this nature, just watch. If you have Na sodium carbonate react with hydrochloric acid. Now first to last and last to first. So when this react, you have sodium chloride plus carbonate, hydrogen carbonate. Now this is carbonate. Now this carbonate, now if you watch, hydrogen is 2 here, hydrogen is 1, so it cannot work, so you have to add 2 here. So when you add 2 here, chlorine becomes 2, so you add 2 here, sodium becomes 2, the equation now becomes balanced. But this will not remain like this, will decompose on heating. When this decomposes, it will form water and carbon dioxide. This is a liquid and this gas will evolve. Now if you watch very well, the number of mole, this is the base, this is the base, and this is the acid. This is the base here, this is the base, and this is the acid. I'm just using this to show how to get the molar ratio of the acid and base. Now this is the acid, this is the base. So what is the mole ratio here? The mole is determined by the value that you see here and here. So that is the value that you can find out here. The only value you can see here is on. There is one that you cannot. So you cannot just put 1 here. So that means here is 1. Say Na. MB here, because this is the base, is 1. Now look at here, you have 2 here. So for acid here, Na here is 2. So the number of acid here is 2 and the number of base here. But when you watch at this equation, here now it doesn't have any value other than on same 1. So the number of base here is 1, the number of acid here is 1. So just relate these two things. So here now we'll say that Na is 1 and MB is equals to 1. Now because of that, now we have to consider and put in the values into this equation. So into this value, so now say that CAVA is equals to NA all over CBVB all over what? MB. So with this, we now say this is equals to CA is given from this equation. This is CB 0.022 times let me say mole per dn cube times the volume of base, so the volume of acid, which is this dn cube, over CB is not given, times 0.025 dn cube, which is VB. The VB is given, which is this, which is equal to 1 over 1. So if we cross multiply this, then this will multiply this. Then we have CB times 0.025 dn cube times 1 is equals to 0.00, this is 2 mole per dn cube times 0.04247 times 1. So when you multiply this, we now say that CB is equals to 0.200 dn cube, mole per dn cube, multiplied by 0.04, this is dn cube here, 0.4247 dn cube divided by 0.025 dn cube. Now with this, now dn cube can cancel out dn cube. So what we have here now is CB is equals to this value now multiplied by that value. So when you have that, we now say 0.20 multiplied by 0.4247 is going to give us 0.0088494 divided by 0.025. This will give us mole per dn cube. Therefore, CB is equals to divide this by 0.025. This is going to give us 0.3398 mole per dn cube. So this is what it's going to give us. So we have gotten this. At this point. Now, what is our next way of solving this problem? We need to check the next problem. So our value for CB now is equals to 0.3398 mole per dn cube, which is approximately 0.300 mole per dn cube. Now, the next question. Look at the next question. So we should find the concentration of B in gram per mole. The concentration of B in gram per mole. Concentration of B in gram per dn cube. So in calculating that is the number two. We need to consider this by applying the formula. Concentration, or can say that molar concentration, formula for molar concentration given as mole per dn cube is equal to mass concentration in gram per dn cube is divided by the molar mass. So what are we looking at? We are looking at the concentration of B. So concentration of B is the base, and this is the base, sodium bicarbonate. This is the base, sodium bicarbonate. So what is the molar mass? The molar mass of this, molar mass of this is equals to, now look at this. From here, we have the molar mass of this. Now, how do we get the molar mass? We have to look into this. Sodium is 23 here. Sodium is 23. So we have 23 there in that question. Sodium is 23. We have 23 there. So sodium is 23. Since we have sodium as 23 here, so we now say 23. So you can see that sodium bicarbonate is what we have here. And we are looking for the molar concentration because we want to calculate the mass concentration of this sodium. That's what we say we are looking for the mass concentration. Look at it. To say concentration of B in gram per dn cube. So we are checking the concentration of this. From there now we need to first of all get the molar mass, because if we don't have the, you see in this question molar concentration is already given. We already got the molar concentration from the solving. We have got, look at the molar concentration. This is the molar concentration of B. And since we have gotten the molar concentration of B, and here we have the mass, the molar concentration the molar mass can only be be achieved by trying to check the relative molecular mass. Therefore, by doing that, we have N here is 23. N is 23. Look at it here. N is 23. Look at it. Anyway, I see N put what, which is sodium, plus hydrogen is 1. So So since hydrogen is 1, I say plus 1 plus, we have carbon is 12. Look at carbon is 12 plus 12 plus oxygen is 16. Oxygen is 16, which is here. Oxygen is 16 here. Times 3 because of this value 3 here. So 16 times 3. So this is going to give us 23 plus 1. Sorry, plus 1 plus 12 plus 48. This is going to give us total value should be this plus this give us 40. This 24 plus 12 give us 36 plus this give us 84. So it's going to give us 84 gram per mole. So when we have gotten this as 84 gram per mole, we now try to substitute values into this place. Therefore, since we have the molar concentration of B is equals to mass concentration of B in gram per dn cube divided by the molar mass in mole, sorry, in gram per mole, So here now we have already gotten this, which is this value here. This is the value we have gotten here, so we have to apply this value 0.300 mole per dn cube is equals to mass concentration is not given, so we say mass concentration of B all over in gram per dn cube divided by the molar mass, which is this mass 84 gram per mole. So this gram we cancel out this gram, and this gram we cancel out this gram. Mole, the gram we cancel out this gram. I think that should be it. Yes, the gram we cancel out the gram. So this value here, we now say that 0.030 is equals to MCB. Is that true? In gram per mole, no, sorry, we are missing something. We cannot cancel out this like that. You don't cancel out. So what we need to do is to multiply. We cross multiply this. When you cross multiply, you have MCB is equals to 0.300 times, sorry, we have to put this, I think, let's leave it like that. Let's leave it like that. So this is 0.030 times, because we are cross multiplying, mole per dn cube multiplied by 84 gram per mole. So you can see that mole can cancel out the mole based on mathematical equation. So MCB is equals to this 84 times 0.03, this times this 0.03 times 84 will give us 28.54 gram per dm cube, because this has gone, this is here. So that is how to solve that. Now the next question we need to handle is the concentration of A. Concentration of A in gram per dn cube. So concentration of A in gram per dn cube, the same formula we applied, the same thing. So therefore, we'll now say that concentration of A Ca is equals to MCA. This is also the concentration of A in gram per dn cube all over the molar mass of A in mole in gram per mole. So A is already given. A is the concentration which is given in this question. This is concentration of A already, which is here at 0.002 is equals to, this is not given in gram per dn cube, is not given, all over the molar mass of A. A is what? To get the molar mass, A is hydrogen chloride, which is this, or hydrochloric acid. So this is hydrochloric acid. To say that the molar mass, from the molar mass, hydrogen is 1. Look at it, the hydrogen is 1. We have the hydrogen as 1 here, but the hydrogen is 1. So hydrogen is 1 here. So this is 1. We'll now say that We'll now apply it here. Since hydrogen is going to say 1 plus chlorine is 3.5. Chlorine is 3.5, 35.5, sorry, which is equal to 36.5 gram per mole. So we will now have to put it the value here. We're talking about molar mass of A, which is this. So we'll now put it here 36.5 gram per mole. So we cross multiply again, So therefore MCA, which is mass concentration of A, is equals to 0.02 mole per dn cube all over 36.5 gram per dn per mole. So here mole cancel out mole. So what we have here is MCA. Sorry, what is the problem? So we have cross multiply, we have is equivalent to MCA is equals to this time this give us back this value, then this time give us 0.200 mole per dn cube. This time this is now what we have. This cross multiply this, we have this now, because this value now is this value that we are having here. This value is a molar mass of hydrochloric acid, giving us this hydrogen is 1, where chlorine is 35. Look at it, I just add it up, 1 and 35. So when you have this, when you get this, you have to put the value here. This is molar mass of A. Molar mass of A in this equation. This is the molar mass of A. So when you have the molar mass of A, which is this one, and you put this value here, this one is not given, this one is given from the equation, which is this. So from there, we'll now do cross multiplication. So this multiplied by this times 36.5 gram per mole. Therefore MCA, which is the mass concentration of A, which is the acid, is going to give us 0.200 times 36.5 is going to give us 7.3 gram per dm cube. So when we have this now, we now check for the last problem, and the last problem says the volume of carbon 4 oxide measured at standard temperature and pressure. The volume of that need to be ascertained, because of for you to get the volume of that. So the last question there is the volume, which is VI. So from the equation of reaction, we understand that 1 mole. Look at it here. The equation of reaction. Look at the equation of reaction, so that you will not ask too many questions. The equation of reaction. Look at the equation of reaction. The equation of reaction. You can see equation of reaction. Say that 1 mole of sodium bicarbonate is equal to 1 mole of carbon dioxide. Look at it here. 1 mole of this, 1 is equals to 1 mole of this. Here, 1 is here. There is nothing like 2 here. There's nothing like 2. This is 1. So 1 mole of this equals to 1 mole of this. Therefore, what the amount in 0.025 dn cube. That means this is the volume of this. The volume of this. 1 mole of this is the amount in this. It says is equal to CB multiplied by VB, which is equals to what? The value we obtain from what is our CB? Our CB is what we had here, 0.3398 multiply mole per dn cube times the volume of base, which is the same thing as 0.25 dn cube. So when you have this, now this is what we have here. So at the end of the day, we'll be having 0.3398 multiplied by 0.002. 0.025. This is going to give us 13.592 13.4592 moles. Let's check again. 0.3398 multiplied by 0.025. Sorry, this is wrong. It's 0.008495 moles. Now, when you have gotten that in mole, we now need to go to the next stage of the problem. What is the next stage of the problem? Is to confirm the processes. So this is equivalent. This is equivalent to the amount of CO2 liberated in the reaction at standard temperature and pressure. Therefore, which is that is 1 mole of carbon dioxide occupies 22.4 dN cube. At standard temperature and pressure, STP, which is the value we obtain from here, which is this value now, at standard temperature and pressure, which is this value we obtained here. So we'll now say that 0.008495 mole of carbon dioxide occupies 0.0889495 times 22400 centimeter cube, which is equal to 22400. Is going to give us no, are you sure? Okay, we have 0.008495 multiplied by 22400 is equals to 190.288 centimeter cube, which is divided by 1,000. Divide this by 1,000 to decimeter cube, you'll be having, which is equivalent to 0.1903 decimeter cube. That is what is required on this problem. Thank you very much, and watch. So please try to copy. So try to follow us and practice this. Don't forget to subscribe. We beg you, subscribe, share with your friends, and try to recommend our channel to other persons. I bet you this is one of the best channels. You will get the latest. Ask question, drop question. Anywhere you don't understand, you ask question. These are the procedures in solving this problem. Like I told you before, these are the procedures. You can look at the question again, take a pen and paper, copy out the question, follow the procedure, follow it bit by bit, and you will understand how these things are properly, how these things are handled. It is not difficult. It requires your time, your effort, and your commitment. That is what is required in science related subjects. Thank you very much, and God bless you as you subscribe. Thank you.